So good afternoon to all. This is uh, NIT Raurkela HRMS lab. I am Gopal Krishna, the technician of this lab. So today I will demonstrate you HRMS equipment and how sample is prepared and how a sample is tested in this lab. So first basic introduction about this lab. This equipment is HRMS and the name of this equipment is HRMS, High Resolution Mass Spectrometer. I have to see here, right? High resolution mass spectrometer. See, this out of all the spectrometer, HRMS is the most accurate one. It will give you the data up to exact data up to 4 decimal places. So its accuracy is too high. So that's why we generally use this mass spectrometer out of all. This is the best. And also one more thing, when we will go forward, what is the use of this equipment? So the main uses of this equipment is you have to find out the exact mass of any compound. Then we will come here. This will give you any exact mass of any molecular compound or whatever it is, compound or ions or whatever in the sample you have. It will give you exact mass. This is the primary use. Secondary use, you can also say that means here you can also identify the various isotopes of an elements or compounds. Means if carbon has isotopes or chlorine has isotopes, because of in isotopes, because of mass differences, this instrument can detect the various different isotopes of an compound. So the second use will be to identify or to check the isotopes availability or in that compound or not. That's it. So this is the basic requirement. This is information. So next we will go for some basic animation, how the different parts are there in this instrument, and we will see how sample is inserted, and then what will happen with the sample, and finally how the result will come. This we will show with animation. Then second part we will go with sample preparation part, and then I will go for testing part. We will discuss three parts. So let's come to animation video, how it works and basic principles. Yeah, here we will see the different zones of it in this instrument. What are the different various parts and how it works. So there are different zones here. You can see it. If we will go forward, see, this is the first section is sample vaporization chamber. Here the sample will be get vaporized due to high heating. Next we will go for ionization chamber. Here sample will be converted into ions. Then third chamber will be ion accelerator chamber. Here speed of the ions will be accelerated. Then the final and last, it is main important, mass analyzer. Here it will be defined, means it is defined which one is lighter, which one is heavier, and this is the basic principle. It will means this whole instrument works on the basis of mass, which one is heavier and which one is lighter. So this is mass analyzer, and then finally if we will go, see here some magnetic field are also there. Now see, sample are inserted from the inlet chamber. It will get vaporized here. Let's pause once again. Here see, sample either we are inserting the sample. We can insert the sample either in liquid form or either in solid forms. So whatever the sample we have, we can do. Here if it is liquid, then we have to, there are two different methods. If a sample is solid, then either we have to do it we have to dissolve it in a solvent, or we have to do directly in solid phase. So we can do like in both way. Here sample get inserted, and due to heating it get vaporized. There is an electron gun here present here, which will convert this into ions. See here ions created, and here also I will inform you there are two different modes here, especially two different modes, positive mode and negative mode. Positive mode means the instrument will detect only positive ions. Okay, in negative mode it will only detect anions, negative. Here it is this in emission only positive ion. Basically generally we will do only in positive mode. Negative mode, unless until it is not required, means in special cases we will do in that case. Here ionization happen. Now the one thing here, it will be there fragmentation. It will split into various parts. Whatever the possible outcome may be, it will get fragmented here. You can see here, and all are the charged particles, and it will go to an electric field. Here electric field will be there, and this field is only to accelerate the charged particles, and then finally it will go to mass analyzer part, and here the things will be decided, which is heavier and which is lighter. And one more, how can you identify which one is easier or which one is lighter or which one is heavier? On the basis of their radius, path of radius, on the basis of their path of radius. So that's why this portion is a curved portion. And here finally detector will analyze which one is heavier and which one is lighter, and then amplifier and amplifier will send the data to recorder, and this is the recorder. This is the recorder where we will see the graphs. See, the graph will come here. Okay. So this was the basic animation part, where we can see that how sample is inserted and how sample is going on inside the instrument and what is happening in the last option. So now we will discuss how sample is prepared in this for this equipment. So this is the first C. Sample can be either directly in the solid form. Here you can see this is the solid form, or either directly it can be in a liquid form. Sample can be like this. Okay. So if sample is like this, so we don't need to do anything, but just we have to check it is completely dissolved or not, any precipitate is available or not. If precipitate is available, then we have to do another way to find that precipitate, because if any something is present here, particles are present here, so it will block our that capillaries. That capillaries size is very thin, very thin. We will show you when we will go there. Okay. So we have to first make sure that no precipitate should be available here if it is in solvent, if it is in liquid form. Next step, when we will dealing with solid sample, then there are as I told you, there are two different way we can do directly in a solid way, or in just like we have to dissolve this solid in a solvent, and solvent should be 4 grades. We generally use 4 solvents: water and methanol and acetonitriles and isopropanol. We use only 4 these, because sometimes but sometimes other lab can also use chloroform also, CCl-methane or also. So the main thing is you use any solvent, but the main important thing is that grade should be LCMS grade. We cannot use any general solvent here, because here purity is very important. Purity is very important. So if your solvent is not impure, then definitely your data will be, some error will be come there, maybe chances of there. That's why that purity should be very high. And even if you did one solvent, I can show you. See, let's see. If something is present, let's suppose if something is present and we are not able to dissolve it even after with here sonication. If we are did sonication and then still we are saying that it is not getting dissolved, then the last option we will use this syringe filter. So this will filter your precipitate part, and it will only solvent, that liquid part will come, and then we will use that liquid part there. Okay. So I will show you how to sample is prepared. See, this is only, I think, acetonitril. Maybe you can see this requisition form. This is requisition form given by a student named Jana, any Madhushri Jana. She is here a PhD scholar. She is doing research here. So she asked one sample. This sample code is, her sample is here. See, this is SCFC monothio, like this, naming like this. And so here this SCFC monothio, here formula molecular formula is given, and then molecular weight is given, and exact mass is given. So when we will analyze this sample, this exact mass should come 350.216. Here mass is there. So when we will analyze this, the molecular mass should become 350. So we will C has given in directly liquid form. So we will not do anything here. Any solvent we will not use. Just, but also C has also recommended about her solvent. Means you will come with different types of compound, and compound will be dissolvable in different solvents. Means you cannot means say that means a sample will be dissolved in specific. It can be dissolved in any other. So main thing is your dissolvability should be 100%. It is ideal. So she recommended acetonitrile, means her compound is soluble in acetonitrile. So I will use acetonitrile as a solvent. I kept acetonitrile here. So we will use only these 2, 3 or 4 drops are enough to identify. So you can see means what is its precision and accuracy. हाँ, तो सैम्पल प्रेजेंट कर दिया था, इसको हटाते हैं. हाँ, इसमें डाल दिया हूँ ना मैं. हाँ. So I have kept this sample in this Asian solution. So now we will go with the instrument, and we will fix it there, and we will analyze the compound, this compound. Let's go. So let's see 1, 2, 3 parts, important parts here. So this is the inlet chamber here, A, sample A. This is the inlet chamber, and this is the setup for manual operation. This is setup for manual operation, and this is the setup for automatic. Here you can do sample one by one. Here you can do sample one by one, and every interval means after one sample you have to clean the equipment also. But in there you have no need to clean manually. It will clean itself and go for the next sample processing. So I want to show you here. See, this is the automatic portion here. So this is the tray. Here, just like in Excel sheet, A, B, C, and 1, 2, 3, the address is given here. So you will fix the sample accordingly, A1, A2, B2, and B2, whatever you want. Here generally we use 2 or 3 samples. We will do 3 or 3 samples, and then after 3 or 4 samples, we will put a blank, or we will put a only solvent with which we want to wash the equipment. Why washing is important? Because when you will analyze a sample, some traces of that compound will be present in this equipment. So when you will go for next analysis, that trace will come in that sample. So to avoid this situation, we will always clean this equipment after 3 or 4 in this automatic mode, and here we have to wash each and every sample. Okay. So this is the basic. So here also, now I am leaving this portion. I will show you how manual operation is being done. So let's see. Here this tube is going to be used for washing. Now I will stop the washing, and I will put the sample, and then I will go for their software setup, and I will show you how different modes are there, and how you can check the what different parameters, and then we will go for testing. Okay. So this is this was going to be used only for washing. So I am keeping it here. Before putting the sample, we will wipe this strip. Now we will put the sample here. I have kept here. Now we will go for computer setup, and we will use the software to analyze this. We will first, there are 2 or 3 steps are here. We have inserted the sample in the sample chamber, and then we will purge here. The purge option is here. So I have clicked on the purge option. It will take approx 1 minute to get purged, and then we will go for next process, infusion. And before infusion, we have to put the sample in that Linux mass software, and we will save the data, and then we will go for sample analysis. So we are waiting for purging get completed. Purging means I can tell you, purging means it is just like a syringe. The instrument is taking the sample from that option. So it will take, or also even purging will include what I have used another sample in that sample A. So it will wash automatically. It will try to just like you have seen in the hospitals. Doctor will try to wash the syringe with before something, they will try to wash that syringe. That they are same thing instrument is doing to wash that part during purging. And during infusion, that injection will purge slowly, means they will try to flow the solvent in the channel. So purging is washing and containing. Washing and no, we can do whatever we will put, that purging will be done by that. If we will put water, then it will. This dominating peak is 350. This is 300. This is 400, and between this we are getting 350. Right. So before analyzing this sample, we have to keep the data here for processing. I have entered the sample code before analysis, and we will save this information. This information is which different type of mode you want. This is MS operating mode. There are 2 different modes. We can use MS and MS. I will tell you what are the difference between MS and MS mode. So I have saved this information. On which parameter we have to analyze this sample. I have saved, and then I will click on the run button. Now this time sample is going to be analyzed, and we will get the result in 60 seconds. Here the time count is going on. You can see it here. 7 seconds, 8 seconds, 9 and 10. It will go for 1 minute, because I have set the time for 1 minute. It depends upon us what we need. 1 minute, 2 minutes, whatever.
Suppose I have one sample which contains different components. Suppose phosphorus and many other compounds are there. But I want to suppose some particular molecule, I want to check the compound and its amount also. How much
amount it cannot be. Amount no. This is only what specific present or not.
No.
What amount you have to go for another instrument.
So basically a qualitative analysis, not a quantitative.
Yeah. It can show you some about abundance or purity. It can show you,
Okay.
but not means amount. So still it is going analyzed. Now it is completed. See the green signal stop. And now I am going its graph. Before going graph, I will close the instrument, because if we will keep running, then that compound will get spread in all the parts. So we have to avoid this step, because then if we will whatever means if we will allow it to for more time, then the more maximum compound will be component will be get affected, and then washing time will be high. So that's why before for that we will close the instrument, so that flow will get stopped and then washing will be easy. I will stop this infusion button. Now sample is not running in the test. And now we will go for analysis part. We will go into chromatogram, and then here graph is there. See, this is the therapeutic part. This is see, its result was 350.216, 216, but here something is 350.022. Yes, minor some difference is there due to some impurity. Means this data is exactly accurate. See, and also you can see that there are a lot of peaks here. These peaks are due to the fragmentation of that sample. That maybe that compound can be fragmented in any possible parts, whatever its nature, depends upon its nature. It is not in our hands. It can be it should be fragmented like this. No, it can be fragmented only by the instrument. Okay? So one thing we can do also, we will run again this sample. I will show you why we are running, because I don't want these peaks. We don't want these peaks, unnecessary peaks, because we know that this is our peak. So we will go for another approach. First we will start the infuser again. I started. Here we are seeing that a lot of other peaks are also available. So we will try to reduce that peak. Now it is stable. Now we will try to reduce these peaks, and how we will reduce this? By changing the temperature, voltage inside the. Now I am going to decrease the voltage of this instrument. I am just trying to get the clear peak and no other peaks. So now we will scan once again. So once again, and then maybe chances we will get the most peak in larger abundance, and other the peaks with less abundance. This was our previous one, and we can also give this data 350. And for the minor calculation, means they are asking for 350.216. We can try. There is one software. In this part, in the same software, there is one part by which we can this instrument error we can adjust. So by adjusting that error, we will get this data 350.216, and then means the sample this compound given by the student is the same compound what she need. Okay.
This is WD XRF. There is another kind of XRF, that is ED XRF, but here we are using extra crystal, that is it is called wavelength dispersive XRF. You can see analyzing different analyzing crystal. Acha. Before this demonstration, I want to say how to prepare sample. We are basically use rock sample, soil sample, sediment sample, sand sample also, and different ore sample. Beside that, we also use analysis different type of metal sample. For for soil, sediment and rock sample, we use powder sample. We generally take 6 gram of powder, and that must be 75 micron, and uh, after that, with this sample we use binder. There are two type of binder we use. One is boric powder, another is cellulose powder. Cellulose, but basically we use boric powder. With this boric powder, we take 6 gram of sample and 0.6 gram of boric powder. After mixing it with, we use press pellet. In this section, we have a press pellet. We use 20 kiloton, 20 ton press pellet. After that, we will get a press. It has a diameter of 40 mm outer surface, and we there is another holder, sample holder. Please. And we use this holder and put this sample just like this, and after passing this a tube height adjustment, we put it. There is a sample chamber. There are 2 row in the sample chamber. At a time we can analysis 12 sample, but as our backup is not more than 45 minutes, we generally put 3 sample at a time. And in this analysis, we can analysis 2 type of analysis we can done here. One is quantitative analysis, another is qualitative analysis. You can see from a data, this is a iron ore sample, and this is a qualitative analysis chart. You can see different curve, different scale. This is a 2 theta scale, and it is intensity scale from calcium, and this is Ka means K alpha. This is for calcium, this is for potassium, this is Si, this is aluminum. But in here it is a combined graph, and we will get a third set of data. You will get a, that is quantitative result. You will get a mass percentage of this component in oxide form. Suppose it is iron ore sample. Iron is 97.9%. Maximum is iron ore sample. Or any other question? Sample basically. In XRD, you can also use for qualitative. You can get a element. For XRD, you can, but here you will get a ready-made data. The advantage of this machine, in this machine we have 2 type of detector, proportional counter and scintillation counter. But this detector has already matching library. You will get after the analysis, you will get just a ready, just like PDF. You get already is mentioned, all this element is mentioned. But XRD, you have just intensity bus 2 theta graph. You have to match with JCPDS database, and then you have to draw these peak values of this element. But here you can you will get just already all these identified elements of this element, and you will get wavelength just like this: nickel, iron, chromium. The height of this iron, the wavelength height, X-ray intensity height is much. So compared to this reference material in this detector is already there. With this height, the detector can identify how much amount, how much quantity is present in this sample with this height. And with this peak, suppose in a sample iron, cobalt, nickel is there, you will get of this wavelength of this iron, cobalt, nickel according to the element present in this sample. In suppose iron is present, this is a iron ore sample. The iron peak, you can identify this. Iron is present 97.9%, and then in magnesium oxide, MnO, all other element is point something. You can see the graph. The iron is 97%. According to the height of this wavelength compared to intensity of this X-ray, the detector itself is a library.
The height of the peak or the
नहीं नहीं, height of this height of this compared to the reference material, the height of this.
Good afternoon all. So this is the this instrument is the ion chromatography system, ICS. Okay. So as you know, there is two kinds of ions are there. One is cation and the one is the anion. Okay. So basically, the ion chromatography based on the principle, that is the first one is the affinity chromatography, affinity, and second one is the ion exchange chromatography. Okay. So there are different kinds of chromatography. Basically, it is based on the affinity. Okay. So in this instrument, we have 6 cation and 7 anion. Okay. As you can see, there are in anion, fluoride, chloride, nitrite, bromide, nitrate, phosphate, and sulfate analysis can be possible. Okay. If we look into the cation part, then 6 cation analysis can be possible: lithium, sodium, ammonium, potassium, magnesium, and calcium. Okay. So the all cations and anions will be quantified in ppm level, parts per million. Okay. As we know, in chromatography, there are two phases. One is the mobile phase, another one is the stationary phase. For cation, the different kinds of mobile phase will be there, and for anion also different kinds of mobile phase will be there. For cation, we are using methane sulfonic acid MSA, and for anion we are using sodium carbonate and sodium bicarbonate. Okay. Okay. So we have 6 cation standard and 7 anion standard. Okay. So basically, if you look into the instrumentation part or parts, so this one is the guard column, as you can see. This one is the guard column. This one is the main column, and this one is the suppressor. So the ion of interest can be separated. Okay. So first we will arrange guard column, then main column, and so thereafter suppressor will be there. Okay. So this is the instrumentation part. Next one is the sample preparation part. Okay. For preparation of sample, we need 1 ml syringe and syringe filter. Okay, what the sample should be in liquid form. So before inserting into the instrument, so the sample should be filtered in 0.22 micron syringe filter. Okay, so here is the, we need to insert the first syringe filter first, then we need to suck the sample and we need to insert the sample over here. Okay. So thereafter that will be separated through guard column, then main column, and suppressor will be there. Okay. So this is the instrumentation and sample preparation part. Okay. We have one is the milky water, then we have 2 bottles, for one for cation mobile phase where methane sulfonic acid will be there, another for anion mobile phase where sodium carbonate and sodium bicarbonate will be there. Okay. And the data will be generated in this format. If the lithium, sodium, ammonium, potassium, that will be in the ppm, that will be quantified in the ppm. Okay, any doubt? Okay, so guard column is the, in order to protect the main column, there is a guard column is there. And like in aquaguard, there is a pre-filter is there, it's kind of pre-filter. Okay, so main column, here there will be a principle of that is affinity chromatography is here. If this guard column, main column, and suppressor, that will be different. Okay, for cation we are using separate guard column, and for anion we are using separate guard column. For anion and cations are also main column will be different. This is for cation, another one will be for cation, and suppressor also different. For cation specific suppressor and anion also specific suppressor, but it will look like similar. Any other doubt? Affinity ion exchange. If the sample will be passed through, okay. So the specific, suppose if this is the cation exchanger, okay. Then the cation will be stick to it, and anion will be come to from eluent, that will come to the discard mode, okay. And thereafter, when the mobile phase will be there, in the mobile phase, that will be that only cation, that 6 cation, the respective cation will be elute out, and there will be detector will be there, and where the quantification can be possible. So before we have seen the ion chromatography system, so that is for ion analysis. Another instrument is there, ICP-OES. ICP-OES, inductively coupled plasma optical emission spectroscopy. Okay. Have you heard the instrument that is AS, atomic aberration spectroscopy? No. Okay. So where around 3 to 4 element can be analyzed before that. So that is the lower version of that. So this is the advanced version of that, where all the apart from 4, around 20, 24, 25 elements can be analyzed. Okay. So in ICS, we are analyzing the ions, cations and anions. Here, element analysis can be possible. So right now we have, as you can see, the green marks shown over here. That element can be wherever the element, where the green mark is there, that element can be analyzed here, because we have standard for that. If you have other standard, then analysis of other elements can be possible. So as like as I see the sample also, sample should be in crystal clear liquid sample. Okay. So the sample should be filtered in 0.22 micron sieving filter, and that is the sample preparation part, and we need 15 ml falcon tubes. Okay. The sample volume should be more than 13 ml. Okay, where nitric acid is also there, 1% nitric acid is also added. Okay. So these are the sample preparation part. Next we have the sample placing part, that is the, here we can put our sample, respective sample can be put over here. Okay. So here, this is the auto sampler. Okay. So if we don't have auto sampler, there is a manual sampler is there. We need to insert the respective falcon tubes or the respective sample. Okay, then we can, that analysis can be possible. Then 24 elemental analysis can be possible. Okay, so here there is a sucking of sample is there. Here the 50 ml falcon. So here we need to put the standards. Standard here unknown sample. Okay. Here 60 and here 60. Okay. For that there is a gas is required, that is the argon gas. Okay. The inserted sample, whichever sucked from this sample tube, that will be come through this tube over here, and here the black tube, that is the for gas, argon gas, where there will be aerosol will be found. Okay. Here the excess amount of liquid will come to this and drain through this, and that will come to upper part. There is a torch is there, and here also detectors are there. Okay. If you have solid sample or food sample, then we cannot go directly to this. Okay. For that we need to digest. Okay. For that, there is a micro digester is there, okay, where we need to digest the sample, whether food sample or solid sample or semi-solid sample. Other than liquid sample, we need to digest that sample first in the micro digester. Acid digestion will be there. Then it will be converted into liquid sample, and we need to filter. The sample must be filtered through 0.22 micron syringe filter. And minimum amount of volume needed is around 13 ml. So right now we have 24 standard for the element. Okay. Right now we are analyzing or measuring that 24 elements in ppm level. The main thing is that the sample should be in liquid form. No, no, only 3 to 4 ml will be there. Flame is there. Okay. So we are giving the elements in aerosol format. Okay, the high temperature is there. Okay, where the elements will be um, strike to that particular detector, and that detector will measure quantity. Okay, if you read that S, atomic absorption spectroscopy, then definitely it will be helpful for this. Okay, the again another higher version is there. This is the ICP-MS. This is the ICP-OES, inductively coupled plasma optical emission spectroscopy. Another higher version, that will be the MS, that mass spectroscopy. A specific mass, molecular mass can be possible.
So, scanning electron microscope is based on the principle of focused beam of electrons, right? So, before that, we have to focus on the sample preparation unit, right? So, scanning electron microscope require coating of non-conducting samples with a thin film of conducting metals like gold, platinum, palladium or carbon, right? So, why coating is needed? Yeah, to avoid charging effects. For avoiding charging effects, we need to coat the non-conducting samples, right? So, in a sample preparation unit, we need the stub holder. We need the stub holder, carbon tape, aluminum foil, and blower. To remove the dust particles, we need blower, right? Then, after sample preparations, this is the ion sputter coater where we coat the samples. It needs 12 seconds to coat all the samples. After that, we take that samples into the same chamber. Okay. Then, after that, we analyze the sample through the software. Here we can operate the samples in the vacuum environment, right? Why we can operate in this samples in vacuum environment? Any idea? Anyone? Yeah, exactly. Okay. So same require vacuum environment to analyze the samples, right? Without vacuum, without vacuum, the samples, the air molecules can collide, and it scattered and diminishing the quality of the image, right? So we need the vacuum environment. After we can insert the sample, we here one button is there. Here we can vacuum the entire machine, right? Then here the source, electron source is tungsten filament. I can see. Here electron gun is there where tungsten filament is placed. Here electrons are generated up to the voltage of 1 to 40 kV, right? Then electrons are accelerated in a high speeds. It going through the sample surface. Here detector can measure the sample composition, sample elemental analysis is going there, and there are three types of detector is present. There is a secondary electron, backscattered electron, and X-ray. Right. In secondary electron, we can only analyze the image topography and surface. In backscatter, we can analyze the composition of the element, composition of the sample. And in X-ray, we can analyze the element of the samples, right? Then in here is another system is there, EDS. What is EDS? Anyone? What is EDS? EDS is electron dispersive X-ray spectroscopy, right? Here we can analyze the analyze the elements. Only elements we can analyze here. And one question is there: why in same only black and white image we can get? Have you ever seen colorful images of same? Why? Can anyone detect what is that? Hmm. Housefly. This is Drosophila, fruit fly. Okay. This is the eye of the Drosophila. Okay. So this is one of the biological sample. Okay. Here there is a treatment which we can analyze in the sample, and here you can see what is this. What are they? What are they? What are they? This is fruit fly. Okay. This is the eyes of the fruit fly. Okay. क्या है? Cone cells. Rod and cone cells. हाँ. Can you differentiate our vision and human and fruit flies vision? Any different any differentiation is there? Our vision and fruit fly vision. कुछ अलग नहीं है. हम लोग जो देखते हैं वो लोग भी वही देखते हैं. मक्खी का अच्छा होता है कि हम लोग का अच्छा होता है? Our vision is better than their ना? Yeah, any doubt is there? डाउट में है कोई कोई डाउट में है कि उन लोग का अच्छा है ना? उन लोग का अच्छा है, डाउट है ये, क्योंकि बहुत सारे दिख रहे हैं, इसीलिए लग रहा है कि उनका विज़न ज़्यादा अच्छा है। नहीं, हम लोग का विज़न ज़्यादा अच्छा है, उनसे बेटर है। देखिए, जैसे कि हम लोग एक एरिया लेते हैं, ठीक है? हम लोग एक एरिया लेते हैं, हम लोग का आई सर्टेन एरिया को देखते हैं जैसे, ठीक है? लेकिन उन लोग का क्या है, ये एक-एक जो पार्ट है आप लोग देख रहे हो, ये एक-एक जो पार्ट है, ये एक-एक एरिया को कैप्चर करता है। सारा एक ही बार में नहीं देख सकता, ठीक है? सारा एक ही, हम लोग जैसे सारे एक ही साथ देखते हैं, ये नहीं देख सकते। ये लोग एक एरिया से एक कैप्चर करते हैं, ठीक है? ये जैसे ये है, ये सामने में जो इतना सा एरिया है वो ही देख सकता है, सारा नहीं देख सकता हम लोग के जैसे, ठीक है? तो हम लोग का विज़न ज़्यादा बेटर है, ये कन्फ्यूज़न नहीं रहना चाहिए, नहीं तो हम लोग उनसे ले लेंगे और हमें आइसोलेट करके लगा लेंगे फिर, ठीक है? तो इसमें जो इलेक्ट्रॉन बीम है वो क्या करता है, रास्टर स्कैन फॉर्म में सैंपल सरफेस को स्कैन करता है। रास्टर स्कैन फॉर्म क्या होता है, टॉप टू बॉटम, लेफ्ट राइट एवरीवेयर, ठीक है? वो सारे फॉर्म से ही वो स्कैन करता है, जैसे कि हम लोग सरफेस सैंपल सरफेस को स्टडी कर सके, कॉम्पोजिशन को स्टडी कर सके, ठीक है? तो उसके बाद सिग्नल जाता है डिटेक्टर के पास, वो डिटेक्ट करता है, तो हम लोग इमेज एनालिसिस करते हैं, ठीक है? कुछ डाउट? हाँ, आप बताओ। वो तो मैं पूछी हूँ, आप बताओ। एग्जैक्टली, वही है, वो लाइट को कैप्चर नहीं करता है, वो सिर्फ वेवलेंथ को कैप्चर करता है, इलेक्ट्रॉन बीम को कैप्चर करता है, इसीलिए उसका ब्लैक एंड वाइट आता है, कलरफुल इमेज कभी आता ही नहीं है, ठीक है? और कुछ डाउट है? और यहाँ पे सिर्फ ड्राई सैंपल ही हम लोग एनालिसिस कर सकते हैं, मॉइस्चर कंटेंट सैंपल हम लोग एनालिसिस नहीं कर सकते, कंटामिनेट हो जाएगा। बायोलॉजिकल सैंपल एनालिसिस के लिए FEACM वहाँ पे हो सकते हैं, यहाँ पे नहीं हो सकता है, रेंज अप टू 4 lakhs. हाँ, या नैनो रेंज इज जी 500. प्लैटिनम नहीं, गोल्ड कोटिंग, या या हम्म हम्म ओके, so sample will show gold coating. Suppose we coat in gold, okay, then okay, yeah, gold particle में ओके ओके, हाँ हाँ हाँ, ओके, okay, okay, okay. Why gold cannot see? We can't see gold. Why we can't see gold? We saw other images like We insert the sample what we show. That's it. Hmm. Yeah. Certain amount we see. Yeah. We neglect that bit. What we want, we can analyze. Okay. We neglect that part of goal. Hmm. गोल्ड सर्टेन अमाउंट में आता है लेकिन हम लोग उसको नेग्लेक्ट करते हैं, हम लोग उसको मतलब हाँ, क्योंकि वो कोटिंग हुआ है तो वो आएगा, उसको हम लोग मतलब ऐसे ये नहीं कर सकते, वो आएगा। लेकिन यहाँ पे क्या होता है, स्टूडेंट्स जब आते हैं उनको कुछ सर्टन जैसे कि एलिमेंट्स चाहिए होता है, हम लोग गोल्ड कोटिंग करते हैं, जिसको चाहिए होता है वो लेते हैं, मतलब ये सर्टन अमाउंट कितना अमाउंट का गोल्ड यहाँ पे है तो वो लेते हैं, अगर उनको नहीं चाहिए होता है वो नेग्लेक्ट किया जाता है।